Hello and welcome to the Elvatech channel. Today we are going to talk about something that affects all of us: food safety. More specifically, we are focusing on food-grade stainless steel, a material widely used in food production and kitchen equipment. Food-grade stainless steel is essential because it helps to keep our food safe from contaminations and corrosion. But how do we know if the stainless steel we are using meets the strict standards required for food safety? That's where precise analysis comes in. And in today's video, we will show you how it's done. Food-grade stainless steel is used everywhere, from kitchen utensils and food processing machines to large industrial equipment. To ensure safety, the materials used in these products must meet strict international standards to prevent corrosion, contamination, and other risks to health. There are global standards like ISO 22300 and NSF 51, which regulate materials that come into contact with food. These standards ensure that stainless steel is safe to use, non-reactive with food, and resistant to corrosion, which is critical for maintaining food quality and hygiene. Regular analysis of food-grade stainless steel helps manufacturers ensure their products meet these requirements. Failing to meet standards can lead to a serious health risks, product recalls, and damage to a brand reputation. Now, let's talk about how we can analyze food-grade stainless steel using XRF technology. XRF stands for X-ray fluorescence, and it's one of the most accurate and non-destructive methods for determining the composition of stainless steel. The way it works is simple. The XRF analyzer sends beam of X-ray to the sample, which excites the atom in the material. These atoms then emit secondary X-rays or fluorescence, which the analyzer detects. Each element in the steel has its own unique X-ray signature, so the analyzer can quickly identify the presence of key elements like chromium, nickel, and molybdenum. This process happens in just a few seconds, and you can see the result immediately on the screen. This gives you a full breakdown of the elemental composition of the stainless steel, ensuring it meets food safety standards. When it comes to food safety, it is essential that food-grade stainless steel meets certain international standards. These standards ensure that the material used in food production and processing are safe and reliable. For example, ISO 22300 is an international standard for food management, and NSF 51 sets a guidelines for materials that come into direct contact with food. There is also the European standard EN 10088-1, which regulates composition and properties of stainless steel used in the food industry. Ensuring that your stainless steel meets these standards is not just about compliance, it's about guaranteeing that your products are safe to consumers. And that's where XRF analyzers become a key tool. It helps to verify that the right elements are present in the correct amount, making sure your stainless steel is fit for food use. Now, why should you choose XRF for analyzing food-grade stainless steel? Well, first, it's a non-destructive method, meaning you don't damage or alter the sample during the analysis. XRF analysis is also incredibly fast. You get the result in seconds, allowing to quickly verify whether the material meets the required standards. Another key advantage is accuracy. XRF gives you the precise breakdown of all the key elements in the stainless steel, such as chromium, nickel, and molybdenum, critical for ensuring corrosion resistance and food safety. Whether you are a manufacturer or a quality control professional, XRF provides a reliable and efficient way to ensure that your stainless steel complies with international food safety standards. Alright, so today we have 4 samples for our analysis, and as you can see just by their shape, they all are targeted for use in a food production, for keeping your drinks cool or cold, or just to use it while drinking. And we're gonna measure all 4 samples, and we'll see what kind of difference they have, and what of them we can say are reliable and absolutely free to use for food using, like drinks and stuff, basically so that not gonna damage your health or influence in it somehow. And also we will determine which could be dangerous because of the contamination of some dangerous elements in the samples. So let's start with the first one. Let's start with the cup, this one we have here, and also we prepared all our samples so it's clean, has no other contamination on it, and we can just really start our analysis. So we have the sample. The next thing we need to get the right calibration, so we will put the alloy calibration, and we will just make sure that we have the right time and the duration. Here we set it for 5 seconds, but it's absolutely enough for a fast screening of these materials. Basically what we need to do today. So as we are done with everything, let's just turn it upside down and start our analysis. Alright, so we are done with our first measuring of our first sample, and here we have the grade 410S. So basically, looking at the grade and analyzing the composition itself, we can freely tell you that this is a non-corrosion steel, but unfortunately it's not practical for food using. So basically this material doesn't really fit for the food equipment and cannot be named as so. So now let's move on to the second sample, and just at first look it seems like it's all covered with the paint, and in such case it's not really advisable to make such kind of analysis because you have a layer of different contamination. So you need or to take it out or just find the part that is uncovered with any kind of paint or other layers. We have this part as soon as we just attract our head off, and we can measure actually in this area, but as you can see it also has some the surface is not really flat, it has some shape here, but it's not a problem because in our device we have the camera that actually points straight to the sample. It locates here at the nose of the device, and this will help us to find the exact area where we can take a measurement. So, alright, it seems like everything is set and we can measure now. Alright, and we have the result here. So we have the base concentration in this material of ferrum, which basically absolutely good for us, and also we have chromium, manganese and copper, but everything else is just below 1, so we will not mention it. All that we can say here that this product is compliant with international standards and can be used in food production or food storing in this case. Let's move to our third sample. We have the kind of the same situation as here. We have basically the bigger part of our sample is covered with the layer, but we also have some uncovered part is right at the top, and now we can make a measurement here of this part. Just we position our device also using the camera for it, and starting the analysis right away. Alright, so with our third sample, we have the similar situation to our second sample. And well, both of them used for the same specification, so it's totally alright, and it's no wondering with that. But we can say that this material is made of the grade of 202 with the same match of 98%. We also have the base element here is ferrum. We have chromium, we have some manganese, and we have copper, and a little bit, just a little above the 1 is the nickel. It's 1.01. So basically all other elements is just below 1. We will not mention it, but we can make the same summary for the third sample as for our second one. It's absolutely it complies with all international standards and can be used for food production or food storing. And our last sample for today is also, it's kind of a similar to our first sample, in comparison. Well, it's used in the same field, the same area, and for the same task. And basically we're gonna measure this one and just we'll look over it and we'll commit if there are any difference between these two samples. So let's start to make our analysis. Position our device to the sample, just unlocking it, and now we can start analysis. Alright, we have our analysis of our fourth sample, and here we can say that again, this one is absolutely complies with all international standards and can be used for food production, food storing, because we have here 99% match that this one is 302 grade. Then we have a ferrum in concentration of like leading concentration 72%. Also we have chromium, we have nickel, we have manganese, and all other elements is actually below 1, so also we will not mention them. But we have four elements that present in this sample, and which actually can tell us by them and by their concentration, we can make a summary that this sample is absolutely good for using it for food production and storing. So to summarize, of all our 4 samples that we have measured today, we have only one that was made for food storing and is not actually accepted for interact with any kind of food or water for not production but for personal use. In conclusion, using XRF analyzers for food-grade stainless steel is one of the most efficient ways to ensure that material meets the highest safety standards. Whether you are in manufacturing, quality control, or food processing, it gives you the confidence that your products are safe for customers. With Elvatech's XRF, you get fast, accurate, and reliable results without damaging the sample. This helps you to meet international standards like ISO, NSF, and EN, ensuring your stainless steel is up to the task. If you would like to learn more about how our XRF analyzers can help your business, feel free to reach out to us. We are always here to provide expert advice and solution for your needs. And also, if you like this video, just smash that like button so we know you enjoyed it and we need to take more videos on such kind of topics. And this is all for today. Thank you for watching. Stay tuned and see you soon.